This segment covers about 3 weeks worth of material. A lot of time I simply had to get the work done, so I used photos after the fact and commentary to kind of walk you through so everyone can follow along. With that said, here we go, with day 8.
Here's day 8. Finally, we got flywheel, the clutch in, and now we're going to bring the transmission over there and bring it over to our engine. So flywheel, straight from the machine shop, new bearing in it, and as mentioned earlier, the ARVs. This is the same ultralight flywheel I used before. It's competition clutch, ultra lightweight. I believe it's about 8 pounds. That's your factory. B18C5 one, it's in the low 20s. Type R is in about 17. This might be a little too light for a road race application, but again, this has big plans on the road for being supercharged, so it'll be perfect for it. You don't want to go too lightweight on a naturally aspirated engine, especially one that's got fairly low displacement like a 1.6 or 1.8 liter, because you need the inertia from that flywheel to help you keep going. It helps keep your gear changes smooth, and in a drag race application helps give you a little extra oomph and torque off the line. But in the blown application, you're more worried about how quickly can you get in and out of gears, and the extra torque you're going to get from your boost will more than make up for your small flywheel. So you gain the benefit of quicker revs, higher speed shifts. You're not all that worried about the lack of weight. The clutch, I'm going to use a competition clutch 2100. It's very similar to the one that I used again on the supercharged motor from before. However, they've changed the material on this disc just a little bit. The 2100 is pretty unique. It's a stage 2, so it has the torque capacity you need and the pressure feel you want to have, but it uses a full face disc. So the benefit of that is it gives you smoother engagement and a lot less chatter, but still has plenty of bite for your motor. Now this new design has a different type of friction material here that gives you better engagement while also keeping clutch smell and noise down. So, considering this had more than enough torque for my 250 horsepower B16, I'm very confident this will have plenty of bite, plenty of longevity for this new motor, which lasts me thousands and thousands of miles. And here's the pressure plate for that 2100. Again, it gives you that stage 2 style clamping force without giving too heavy of a pedal, and if it can hold my 250 horsepower V16, it's going to last a long time and have plenty of bite even after this thing gets supercharged. So
Alright, the full long block and transmission is fully assembled. Here we are simply raising it up on the crane and bringing it in. I noticed that a bunch of my old wires and the old wire harness were chewed up, so I decided this was a perfect time to basically rip off the harness, redo a lot of the wires, the installation, and basically give it a full wire harness reconditioning. So here's the before, and then afterwards, here we go. We use fire resistant sheathing. In some cases we had to do new plugs. And all in all, not really a wire tuck, but simply just cleaning up the harness and making sure it's in the best condition it could possibly be. Again, bringing it over, dropping it into the engine bay. There we are, right after installation. We had to do a couple of tightening of the mounts, getting some of the wires out of the way. You can see on the left, up in that corner up there, that's actually the main engine harness that is yet to be put through the firewall. Slightly different shot, slightly later, some more of the harness being tucked away, batteries back into place, the main harness is tucked to the firewall. Miscellaneous sensors and hoses are now being put in. The axles are in, the transmission's all set up, and basically I'm just going to test fit the header, make sure clearances are there, and get ready to get this thing started for the first time.
Still running out of time. I'm breaking down my defense.
The factory headers are stainless steel. And so when you first put them on, they do have that standard steel look. They actually over time will darken and turn that bluish, goldish color. And of course, the fit and finish of the factory Type R manifolds, really, really good. There's not much you can really do to it. Here we are now, even more the harness finally put in, batteries back in. Basically, the only thing missing here for the startup is the oil cap. And I think one sensor on the back of the block was still missing, maybe the knock or something. A lot of people ask what this lovely thing is. This is just an old Sony Vaio UX. I think they came out in like 2005, 2006. When they were brand new, they cost about $2,000 to $3,000, and they were so expensive nobody bought them. But nowadays, you can pick these things up for, about $400, $500 in good condition. And it's a perfect little companion for people that have tunable computers. You can plug it in, run your Honda S300 software. It's great for diagnostics, and that's what this thing is. We're doing our first startup. Just had to double check the ignition timing that we were all squared away exactly at TDC, all the gears, the pulleys. Didn't want to skip a tooth on the first start. Again, double checking, making sure all the torque MPZ is still there, so we don't scar up any of the cam lobes or the rockers on their first start. So here we go. Gonna prime the engine right now. Turn the key, I got fluids in, spark plugs are out, ignition's been defeated, fuel system's been defeated. I'm gonna crank it over a few times just to kind of get some stuff going through. This might break everything, I don't know yet.
Go ahead.
What you're looking at here is actually a shot through the oil cap during the first start. It's very, very important that you prime the engine before you start it. You take the spark plugs out. If you defeat the ignition, you defeat the fuel. And you just crank the engine over a couple times simply to start building up oil pressure. There's no oil throughout all the oil passages, and you gotta be able to suck up the oil from the oil pan, through the pump, through the crank, all the way up to get to the top of the head. Otherwise, the first start, that first 30 seconds can be very damaging on your engine. So if you're doing a rebuild, this is a very smart thing to do. And as you can actually see by the end of this, you start seeing the oil begin to pool on the cam lobes. They finally reach the spray bars. After about 30 seconds or so, you'll notice the oil pressure light would turn off on your car, and when that happens, you know you've prime the engine properly, you can be confident to start it.
Oh boy. Here goes $15,000 of essentially nothing.
Alright, by now we've got our S300 doing a break-in program. We're holding the engine at certain RPMs with throttle pressure and just braking in the motor. It's actually very important. You don't want to break the motor in very easily. You only have so much scuff on the cylinder walls to break in the piston rings. The piston rings themselves only have a few pounds of spring pressure. The piston rings themselves do not keep the gases in the cylinder. It's actually the gap and how the expanding gases gets trapped between the upper and the lower rings. So if you do one of these really slow break-ins, you limit the amount of power your engine can make because it's never going to seal as good as it can be. So after that first few miles, the crosshatch pattern on the sleeves is gone, and you'll never be able to get the proper seal at all the higher RPMs. So if you want the best longevity out of your engine, it's very important to do a proper break-in on a dyno and use those first 30 minutes to your best advantage. Once you get enough vacuum in the manifold, getting into the 20s, 25s, you know you've sealed it up pretty well, and then you can start doing your drivability break-in and raise it up 100 RPM at a time all the way through the rev range. And after that 30 minutes, you're basically ready for the races. You can do your first passes and know your motor is as healthy as it's going to get. And finally, the dynograph, something that's sure to be a debated issue. It is a brand new engine. In this case, it was only about 30 minutes after being broken in, still running the break-in fluids, not a high-grade premium oil. And you might say, it's only making 176. Well, that's actually really good. The way our dyno works, it's a fairly, if you want to call it, pessimistic dyno, but it's very accurate to the engine. For example, we've had 2.2 liter preludes come in that, on paper should make 200, and they do their first base pass, and it does 141. It doesn't necessarily mean the car's making that, that little power. It's just simply that's the way it's been calibrated, and that's how the motor's been set up. What you're really looking for is consistency in the dynograph and progression, especially if you come back to the same dyno again and again and again. Looking at the torque, though, you realize it's doing very, very well. This engine on paper was supposed to make about 130 foot-pounds of torque at about 7,600 or 7,200 RPM. Now that 4-to-1 stainless header, it's supposed to actually bring that torque level down to 6,200, and as you can see, it actually did just that. And given the fact that this is reading wheel horsepower, not from the flywheel, getting 129 foot-pounds at 6,200 to the ground is an amazing accomplishment. There's no power loss going through the whole motor. If you took this engine as is to other dynos in the area without changing any programming, you would more than likely start seeing higher numbers, not because of making any more power, but simply because their dynos have been calibrated differently. I'm sure after this motor has a good month or so of driving in it, and all of it sort of loosens up a little bit, I bet you when we retune this thing later on, this number will increase a little bit, just because of the tolerances and everything's finally opened up after a few thousand miles. In order to get this thing to pass through California emissions, we did have to put a catalytic converter on it for the smog test. Now this can prove a little difficult, primarily because that Japanese header is a few inches longer than the US counterpart. Thankfully, you can still purchase 2012 legal universal catalytic converters that can be cut to fit any application. So that's what we did in this case. We made sure that we had enough space, and we were able to get a universal California legal catalytic converter to fill the spot, and it worked just fine, just for our testing purposes and finally for the emission purposes. Here I am driving it into the Bureau for the first time. We're going to see how it passes. Right now I'm not using the Type R ECU, I'm using my old P2T SI computer. We'll see if it's close enough. There seems to be a lot of confusion regarding how to properly state ref your motor swap in California, but the bottom line is it's simply just a very strict smog test. All they're really looking for is if you put in an engine for an Acura, that you have all of the emission control systems that the Acuras in California had. So if you bring in a Japanese engine, they're looking for US intake manifold, they're looking for US exhaust manifold or a CARB legal version, they're looking for a US ECU. If you pass, it's not even that expensive. You only pay about $8 for the certificate. The reason people think it's so expensive is when you start with a Japanese engine, there's a lot of things that are missing that the US ones have. Sensors, brackets, manifolds. It's the missing parts that makes the revving expensive, not necessarily the process itself. Even though this was a brand new US engine, I was surprised they still found a bunch of things that were not quite up to spec. The gentleman in the center there is actually a lead ref, and he was actually teaching some of these students, so I think he was being particularly stringent on this case. As I said earlier, I tried to bring it in with the SI computer, and they immediately noticed that. The things that they sent me back for this first time, I actually had to go back 3 different times. This time I had to go back because the intake that I had, an AM V2, while it's legal for the B16, it is not legal for the Integra, so that was one thing. They said my catalytic converter was not quite in the right spot. I had to bring it back about 2 inches. They were also complaining about the aftermarket's going to billet VTEC solenoid cover that I had. Not so much the cover, but the lower piece, even though it's nothing more than an oil passage. As the years go up and down, some years they're more strict, some years they're more lenient. This just happened to be a particular year where if it's not a factory part that needs to have an emission label on it, because they're taking no chances on all these engines nowadays, especially on the newer ones, 2000s and 2001s, they are particularly stringent on emission controls. To get around the problem regarding the intake, it was kind of tricky, because we needed to have an intake system that was legal for the Integra engine, but at the same time would bolt on to a Civic chassis. What we ended up doing was using a CT Engineering icebox, drop-in filter, and Integra Type R elbow. The nice thing is, the icebox itself is actually for a Civic. It's meant to bolt in just fine. However, the carb numbers that they use for their icebox is the same for a Civic as is for an Integra. So by doing this setup, we had a bolt-on setup that could fit the Civic, but was also state legal for the engine. I then went to a different referee a few days later to get a different overview. This time I got sent back for a few other things. One, the thermal gasket on the throttle body. It was a debated issue of whether or not it was too thick. The previous ref claimed it was too large and it was actually a throttle body spacer. It's a weird judgment call, but it's no big deal to swap out just for this test. So that was the one thing I had to change. Second thing, while the first referee had no problem with the Japanese 4.1 header, the second ref did, and no one could quite figure out whether or not a Japanese OEM header was legal or not. On one hand, it's a factory part, but on the second hand, it was never sold in America, nor is there a carb exempt number for it. Thankfully, we had the cast equivalents for the earlier models that we could swap on, and we were able to pass that the next day. So you can see here in this comparison the very minute changes that had to be done from the second ref attempt and the third. Primarily, the gasket by a throttle body had to be replaced with a factory one. The VTEC solenoid, the Skunk 2.1, had to be replaced with a factory one. And as you can see, the header was also changed. It's actually not even the US spec header, but the 96 spec Japanese ones had a cast iron header. And the reason this was beneficial was it was still a 2.5 inch outlet. It would still bolt on to our existing cab without modification, and it looked almost identical to the US spec model. As soon as they saw the cast iron, they were cool with it. After visual, we went on to the tailpipe test, and it was just a matter of waiting if it would finally pass just tailpipe. And finally, on the third try, it finally did. Like I said, it took a real US spec ECU. It took a US style, in this case, 96 spec Japanese header. It took a regular gasket on the throttle body, a OEM VTEC solenoid, and everything else was just right by the books, and we were able to pass it as a 2001 that was more strict than the car originally came as. You can see him cleaning off the strut tower bar here, and then finally placing the decal that basically says, as far as the state of California is concerned, this is no longer a Civic, this is now an Integra. So for all future modifications, it has to follow Integra spec, whether it's an Integra header, an Integra intake manifold, you name it. Here you can compare the two. On the right side is the 96 and 97 spec Japanese header. On the left hand side is the 98 and up. The US models had a cast iron header similar to the one on the right all the years around. The only difference actually was the upper piece. As you see in the Japanese model, it's a cast top, but it's a tubular cast top. Whereas in the US models, the upper piece is a single piece, very similar to how US B16s look, but the lower part was the same. And again, from the visual, once the ref saw cast iron on it, it was totally cool, it was good enough. And thankfully, because this was the Japanese header on the right, and I originally test fitted with the Japanese header on the left, the clock position for the cat was the same, the length was the same, it was a simple bolt on, run the test, and then we came back, we put the Japanese one back on. And last but not least, after the ref was finished, I head back to my local Acura dealer, and we were able to pick up the underhood emission label for the engine. So all the vacuum lines line up to the diagram, and it states exactly that it's a 1.8 liter, meets 2001 specification, and in the future, if a smog technician needs to run the test, it has all the serial codes needed to pull up the right test procedure. And again, for the most part, reffing an engine is not that difficult, so long as you plan ahead and you choose an engine that's relatively easy to convert. Earlier model Civics are very difficult, or at least more challenging, to run B16s simply because there's fewer US models to clone. If you have an OBD1 vehicle, then the car you're trying to match is a Del Sol VTEC, and those are very hard to find. There's only a few years those even existed. And finding the ECUs for those, the manifolds for those, can be a real pain. So in most cases, if you really want to ref your vehicle in California, it's much easier to use the GSRs, because those existed for many, many years, and those ECUs and components are all over the junkyards. If you have a Japanese spec Type R block, a B18C, again, all you're doing is trying to clone a US spec version. If you're trying to find the US spec ECU, US spec manifold, and the various emission controls from it, the only Japanese B series that you cannot ref is that from a Civic Type R, simply because there was no 1.6 liter B16B engines in any US vehicle. So if you're running a B16B in California and you ever get stopped, I'm sorry, there's not much you can do other than pay the ticket. But everything else, so long as you follow the procedures, it's not that difficult, and if you plan ahead, it should be very straightforward.